Welcome students. Now let us begin with a new topic, capacitance. Capacitance is a very important topic. There are a lot of numericals in it also. Okay, let us do it. So before coming to capacitance, I have to discuss one more thing, the behavior of conductors in an electric field and when it is charged. Suppose we are keeping an electric conductor in an electric field. See, something will happen inside it. Let us see, look what is happening inside it. In the similar way, when you charge a conductor, something is happening inside, some changes are happening inside the conductor. Let us study first that and then we will pass on to capacitors. Suppose this is an electric field E in this direction. And imagine that you are keeping a conductor inside this field. Imagine that this is a positive plate and this is a negative plate, and in between, so there will be a electric field in this direction, and I am keeping this conductor. So imagine that this is a conductor in the electric field. Now let us see what happens inside it. So in order to make an electric field, what you have to do, you have to keep a positively charged plate here and negatively charged plate here. So there will be an electric field in between from positive to negative. That external electric field is E. In that electric field you are keeping a conductor. Now imagine that the electric field passes inside the conductor. Just imagine, it won't pass, but imagine that it is passing through the conductor. Now, what is the peculiarity of conductor? The conductor will have a lot of free electrons inside it. Now, when the electric field passes through inside it, so inside the conductor, these electrons will come into the electric field. What will happen when we place an electron in the electric field? It will move in the direction opposite to the direction of the electric field, because if that is positive plate and this is negative plate, the direction of electric field will be like this, and the electrons will be attracted towards the positive plate. So all electrons will come in this direction, and what will happen? It will come here and accumulate here. It can't jump out of the metal because of the low energy. It should have there is a term called work function. If the energy is more than work function, electron can jump, otherwise it can't jump. So energy is low, that is why the electron will accumulate on this side, and naturally what will happen? This side will become positively charged. Now what will happen now? Now this is equivalent to inside the capacitance, inside the conductor, this is equivalent to two charged plates, positive and negative. What will happen? There will be an electric field in this direction, the E internal. Internally there will be electric field in the opposite direction of external electric field. So what will happen? The electrons are rushing towards this side, positive plate, in the opposite direction of electric field. Now some electrons have already accumulated there, and that will create an electric field, and that electric field will retard the coming of new electrons. The speed of the electrons will be reduced, but somehow they will reach here and get again accumulated. And what will happen? The electric field inside intensity will increase. So what will happen? The electrons will be again retarded, and a stage will come where no further electrons will be able to move. There will be a repulsive force. So at equilibrium, now we say that an equilibrium has reached. That will happen within a fraction of a second inside the conductor. So at equilibrium, there will be no further increase in intensity of internal electric field, and there is no change in external electric field also. And at equilibrium, both internal will be and external will be equal to, will be the same in magnitude. The internal electric field will become equal to the external electric field, then the equilibrium will be attained. So at equilibrium, E internal will be equal to E external in the opposite direction. So E minus will be equal to E external. So what will be the electric field inside this conductor? The electric field inside will be sum of these two, E external plus E internal, but it is equal in magnitude, opposite in direction. So what happens? The electric field inside the conductor will become 0. Thus the electric field inside the conductor has now become 0. So this is what happens when you place a conductor in an electric field. Now what about the potential V? What is the relation between E and V? E is equal to minus of dV by dr. So inside the conductor E is 0. So 0 will be equal to minus of dV by dr. That is dV by dr is equal to 0. What does it mean? The rate of change of potential with respect to distance. The rate of change of potential is 0. When is the derivative of the potential is 0. When a derivative will become 0, a rate of change will become 0. When that potential is a constant. When a derivative is a constant, the rate of change of derivative will be equal to 0. That is, there will be no change. So V is a constant. So inside a conductor, the electric field intensity will be always equal to 0. Now imagine another case. This is a case when this conductor is placed in a electric field. Now imagine another case that conductor is being charged. Suppose this is a conductor and you are charging it. You are giving some positive charge to it. Say, imagine that you are giving one positive charge inside it. You are injecting that positive charge inside it. What will happen? This will produce an electric field in all directions. So inside a conductor, what happens when a field comes? The electrons will accumulate and oppose that electric field. How it is opposing? See, if you insert a positive charge inside a conductor, there will be another atom here. So the one atom will be attracted towards this charge and that will become neutral, and this atom will get positively charged. So another atom will share the electron and this will get positively charged, and there will be on the surface there will be a charge that will give an electron, and that is equivalent to the moving of electric charge towards the surface. That means if you pump some charges inside a conductor, immediately the charge will fly towards the outer surface. From the outer surface it cannot go. So if you charge a body, what happen? The charges will accumulate on its center. See, the charge will get accumulated on its surface. Sorry, not on its center. The charge will get accumulated on the surface. So if you charge a conductor, the charge will automatically accumulate over the surface. It will reside only on the surface. It will not go inside the surface. If it go inside the surface, the electric field inside the conductor will not be equal to 0, and that is not possible. So since the electric field inside the conductor is 0, we have to assume that all charge will reside only on the surface of the conductor. So now you have learned 3 things. 1. Inside a conductor, the electric field intensity E will be always 0. 2. The potential inside a conductor will always be a constant. And third one is the charges will reside only on the surface of a charged conductor. So these things, it is very, very important in electrostatics. So you have to understand all those things. Inside the conductor, the electrostatic field will be, electric field intensity will be 0, and the potential inside the conductor will be always a constant. And when you charge a conductor, the charge will reside only on the surface of the conductor. Now let us come to part. Imagine that you are having a conductor and you are drilling a cavity inside it. Outside it is covered with the conductor itself, metal itself. Inside there is a cavity. Imagine that like that. That means you are making it two half and making a cavity, then closing it. What will be the electric field intensity? Suppose you are keeping inside an electric field, in an electric field. What will be the electric field inside the cavity? Inside the cavity, the electric field will be 0, because if there is an electric field, if there exists an electric field, what will happen? The polarization of electrons will happen here. The polarization of charges will happen there, and the electric field intensity will become 0. So inside the cavity of a conductor, the electric field will be 0. No need that it should be fully solid thing. If there is a cavity, inside the cavity also the electric field will be 0. Okay. Now imagine that you can prove with Gauss law also. Imagine that you are increasing the size of the cavity. Now it has become a shell. So inside a metallic shell, or inside a conductor, a shell made of a conductor, the electric field intensity will be 0. So E will be 0. What is the benefit of that? See, in our labs, see, when in physics labs, there will be lot of equipments, many equipments which has to be, while working, it has to be kept protected from external electric field. There are some equipments like that. So how you can protect it? Simply you keep inside a cavity of a conductor, then that will be protected, because no electric field will enter into it. There are a lot of electric field outside. See, all the radio waves, the mobile waves, everything are electromagnetic waves, and there are electric fields. So in order to protect an equipment from an electric field, what you have to do is you keep that equipment inside a conductor, then that will be protected. So for that, what we are using is, we will make a metallic cage like this. You make a cylinder like the cubical shape or rectangular shape, which is made up of a metal, steel or copper, whatever. You can keep in this equipment inside it. This process is called electrostatic shielding. Electrostatic shielding. And this type of equipment, this metallic cover, is also known as Faraday cages. This is also known as Faraday cages. So someone asks, what is electrostatic shielding? It is a way of protecting equipment which is to be protected by an external electric field by keeping inside a conductor, and that process is called electrostatic shielding, and the cage used for that is called Faraday's cage. Okay, note down on this. So let us go to capacitors. Before going to capacitors, I will tell you an example using water. See, suppose this is a water tank, say 500 liter capacity. This is 500 liter capacity. So you can add water to this. You can fill it with water. As you fill the water level will rise, isn't it? So imagine that you are filling 250 ml liters of water and the height is h1. Now we are filling fully. You are filling it 500 liters. Let it be h2, the height of the water level. Level has rise to h2. Now imagine that you are filling this water. What will happen? The water will overflow. Water will get out of the tank. It can't stand in the tank because its capacity is over. The only capacity is 500 liters. Now imagine that there is another water tank. There is another water tank which is having 1000 liter capacity. Imagine that you are filling it with water. Imagine that you are filling it with water. Now, when you fill it, when it is 250 liters, the height will be say h dash. This is the height. And when you fill 500 liters, the height will be h2 dash. And if you fill 1000 liters, the height will be h3 dash. Imagine, this is the height. So you will say this water, this tank is having more capacity than this tank. See, this tank, big tank is having more capacity with this tank. And what is the peculiarity? See, when the 250 liters of water was filled, the water level was h1. Here, when 250 liters of water was filled, the water level was h dash only, and which is much less than h1. Okay, so you have to understand this example first, then let us go to conductors. Suppose this is a conductor and you are charging this conductor. How you can charge a conductor? By taking electrons out, by rubbing or something like that. You are charging it immediately. Imagine, and this is an insulated conductor. So you are adding positive charge to it, and all the positive charge will reside on the surface of it. Okay. Now again you are adding charges. Again you are adding. How long? How much you can add? Up to what is the limit? There is a limit, because in this water tank you can add only 500 liters. Similarly, this conductor is having a capacity to hold. Beyond that capacity, what will happen? If you fill beyond this capacity to this tank, what will happen? The water will overflow. Similarly, if you charge this conductor up to more than the limit, more than its capacity, this charge will get out of it. How it will get out? See, it is residing in it is placed in a dielectric here. There is some dielectric, say air or vacuum, whatever it is. So if it is, imagine that it is air, there will be some oxygen atom or nitrogen atom, anything like that. This positive charge will get attracted by this one, by the electrons on this one, and there will be a transfer of charge between the molecules. And what will happen? That process is called a discharge. There will be a spark, and this conductor will begin to discharge. If it will hold a maximum up to its capacity, and after that the discharge will take place. Okay, so that is the capacity of this capacitance. Beyond that capacity, what will happen? The charges will begin to get discharged. Now, what about the potential? See, when you initially, when there was no charge, imagine that there is no charge initially. Its potential is 0. I can bring a unit positive charge without doing any work. I can bring it here and keep it. Now slowly I am charging it. So what happens? The potential will increase, similar to how the water level rises. And when it reaches maximum, it will have some potential V. Now, imagine one thing. Initially this V was 0, and gradually the V has started increasing, similar to that of height. Now, so what is the condition of V? The V is proportional to Q. As Q increases, V will also increase. So V is proportional to Q. And removing that proportionality sign, we have to convert it to equal sign. So we have to multiply with the constant, that is equal to 1 by C into Q, where 1 by C is a constant and C is called the capacitance. Why the inverse has come instead of C? Because as Q increases, as water increases, the height will increase, and that depends on the capacity. If the capacity is low, the rise of height will be more. So similarly, if the capacity is low for a conductor, the potential rise will be more. So the potential will be inversely proportional to the capacitance. That is why 1 by C has come. So now we can write V is equal to Q by C, and C is called the capacitance, or C is equal to Q by V. It's a very important formula. So this is the formula for capacitance of a conductor. Capacitance of a conductor is Q by V. Okay. Now let us see what is the unit of capacitance. So, before that, let me ask you one question. What about the capacity of a water tank? It depends on what? It depends on the size. It depends on the radius or the diameter. It depends on the height. That means the capacity of a water tank depends on the dimensions of the water tank. Similarly, the capacitance of a conductor will depend on the size of it, its dimension, its shape, its dimension, everything it will depend on. That capacitance will depend on the dimension of the conductor. Now, what about the unit? What is the unit of capacitance? What is C? C is equal to Q by V, or Q is equal to C into V, like that. There is another formula, say Q is equal to CV. This is also important formula. Now what will be the unit? What is the unit of Q? It is Coulomb. And what is the unit of voltage? Volt. So it should be Coulomb volt raised to -1, isn't it? But that is not the unit of capacitance. The unit of capacitance is farad. It's the name of Michael Faraday. Farad. Farad is the unit of capacitance. You know why it is not, we are avoided using C by V or Coulomb per volt? because that depends on the surroundings, that depends on where the conductor is placed. If you place it inside a conductor where the dielectric constant is high, its capacitance will increase because discharge will be less. There will be only after getting high potential, enough charges, the charges will begin to discharge. So that depends on the dielectric where we are placing it. If we are placing it in air, its capacity will be different. If you keep the same conductor inside water, the capacitance will be different. If you keep it immersed in oil, the capacitance will be different. So that is one of the reason we are not using Coulomb per volt. So no need to go in deep. So the unit of capacitance is farad. So please note down all those things, and from in the next video we will deal with more in capacitance. Okay, thank you.